Ladies and gentlemen, I hope you're good. So today we're doing the last question on the May-June 2023 Maths Paper 2. If you're new in this channel, welcome. Please subscribe. Now let's go to the statement. In the diagram, TR is the diameter of the circle. Now let's wait there. This word diameter, there's a lot of things there. So what is a diameter? I told you before, there is a video about the theorems. A diameter is a special line that goes through the center of the circle, and you know what the line or we know what the angle subtended by the diameter. It is what angle. So this is the line, which is what the diameter. Which angle is it subtending? It is subtending that angle there, which means with our what that P, it is equals to what 90 degrees. P1 plus P2 is equals to 90 degrees because this is the angle subtended by the diameter. Okay, but at the same time, this diameter is also subtending what angle K. So it basically means go to what K1 plus K2, it is equals to 90 degrees. Everyone? Now you know what already what K1 plus K2 is 90 because of what diameter angles in a semicircle. P1 plus P2 is equals to what 90 because of what angles in a semicircle. Okay, so now we are done about the diameter. That is just about that is the only thing about the diameter, that the angle that it subtends, it is what 90 degrees. Now PRKT is a cyclic quad. Now let's wait there. Now when you are now there, you are gonna do what? Your theorems of what? Of a cyclic quad, which is that one and this one. So now let's check if this one is there. So they are basically talking about this whole diagram there, which is a what? Quadrilateral. But from what I can see, I know what P and K are supplementary. They must add up to 180, but I just showed you that K1 plus K2 is 90, P1 plus P2 is equals to 90. So it basically means that they are what? Supplementary angles, right? So now everything it is just fine. Okay, everything it is just fine. But now let's continue. I think that one you're done. So let's go to this one. Can you see something like this? Yes, I can see, because in this one there is a line that is extended outside, line that is extended outside. Because if you can turn it like this one, my exterior angle is this one. So it basically means with this R1, it is equals to that angle there, which is T, because of what those thing what you call exterior angle of what? Of a cyclic quad. Okay, and then let's continue here. If you can also come this side, you can also see that this P3 here, this P3, it is equals to K1 plus K2 because of what? Exterior angle of a cyclic quad. So it basically means we line of what? 90 degrees because of what? Exterior angle of a cyclic quad. Exterior angle is equals to the internal opposite angle. So this one, it is now applied. I've applied everything there. Now let's check. They said what? Chord TP and chord what are produced, and then now I can see that PK and TK are equals. So PK and TK are equals to each other. But now let me see what this thing is for me. As you can see, this is what is a triangle. So it basically means that this one and this one are equal angles that have the what? Same base. You see, isosceles triangle now. Okay, so I feel like now we are done with interpreting our question. Now we can now go to questions, because that's what I can see. So now the first question is that prove, given reasons, that SR is a diameter of a cycle passing through points SPR. Interesting. So now, since I've told you, now I'm just gonna write what answers, because you just have to refer to the diagram. So the first thing that you'll have to do, you'll have to start by saying what this is what 10.1.1. you can see what P angle P1 plus angle P2, it is equals to 90 degrees. What is the reason? I told you same angles in a semicircle. You see, because it was the reason why that one of a diameter, and then manje you can see what angle P3 is equals to 90 degrees. But at the same time, besides that one of saying exterior angle of a cyclic quad, I can also see what angles on a straight line, because they add up to 180. P1 plus P2 is equals to 90, P3 is equals to 90. So 90 plus 90 is what? 180. So I'll choose what? Angles on a straight line. Angles on a straight line, because that's what I can see. So since I can see that this P3 it is equals to 90, so I can now basically tell them that my SR is what? Is a diameter, because that's what I can see, which means I am done. So now this will be what? The converse angle in a semicircle. Okay, so this one is the what? The diameter. So let me write there. So therefore SR is a diameter. What is the reason? You can say converse. I showed you the converse and everything in those theorems. Converse angles of in a semicircle there. Okay, so now let's go to number 2 there. They are saying prove that now you are just prove that S it is equals to P2. S it is equals to P2. Now wake up. Now from what I can see in the diagram there, I told you since PK and TK are equals to each other, it means T1 plus what? T2 are gonna be equals to what? P1, because of what? Angles opposite equal sides, or the angles that have what? Equal chords. You remember that one? So guys, like the minute you can just interpret the questions and everything, you can now go to what? Questions directly and write what? And write the things, because like it's gonna make life easier for you. So you can start by saying what? People are proving that S, so you just have to play going that side. And at the same time, if you're not sure of your answer, just write whatever angle you found. Maybe you might get an answer. It's equals to 90 degrees. Wait, I said P1. It's equals to P1. What is the reason there? Angles opposite equal sides. Okay, angles opposite equal sides. So now let's continue. Now I can say in triangle STK. In triangle STK, what can I see in triangle STK? I can see that angle S, which is this one, plus what? T1 plus T2, and then plus the 90 that I was telling you about. It is equals to what? 180, because this is the sum of what? The sum of what? The sum of angles in a triangle. Can you see what I'm talking about there? Because there's a 90 degrees in this triangle. So now let's continue there. There's a 90 degrees there that I showed you. So now I can say angle S plus. So let me say, put this one in the bracket, T1 plus T2 plus what? 90 degrees. It is equals to 180. So this one is what? Angles, sum of angles in triangle, right? So you will continue by saying, which means angle S plus P1 it is equals to 90 degrees. Do you know now I'm saying P1? I told you here that T1 plus T2 it is equals to P1. So where there is T1 plus T2, I'm gonna write P1 there. So since I'm gonna leave it like this, Mara, I'm gonna say but angle P1 P1, it is equals to 90 minus P2, which is the reason of what? Angles in a semicircle. So now check what I just said now. But what? Angle P1, which is this one, right? It is equals to 90 minus P2. Same thing about the diameter there. And then we're going to continue by saying what? It means S, angle S plus 90 minus P2, it is equals to 90. Then I'm going to sort out the maths. You're just sorting out this thing. So 90, when it goes to that side, it will be what? 0. So when negative P2 goes to the other side, it will be what? P2. Therefore, angle S is equals to P2. You see? As long as you can just try by completing your angles and write whatever you have, you'll be able to write all your answers. I hope it makes sense, guys, because Euclidean is very tricky in a way such that you just have to try by all means. It's not easy to make somebody make you understand Euclidean, but I guess and I hope that you managed to understand whatever that I said there. Don't forget to go to this is what my 90 degrees there. Okay, because I have a 90 degree in that triangle. Don't forget that the 90 degree that I showed you. Because in triangle STK, I have the 90 degrees, which is just K1 plus K2, and then there is T1 plus T2, and there is S. So yeah, that's how it is supposed to be. The statement of saying angle S, you see, angle S, it is equals to T1 plus T2 plus 90, which is what? This one, because it is the whole triangle here. Yeah. That's the whole thing. Let's go to the next question. 10.9.3. Prove that SPK is similar to PKT. That one, it's very easy, that one. I think I'm going to give it to you, but let's do it together. It's fine. So for this one, you're simply going to say in triangle S what? SPK, ne? And triangle PRK. You're going to write all your triangles going downwards like this. So you're going to simply say S and P. And then you're now going to be careful there and check whatever you have. So let me start. My S, it is equals to P2. My S, it is equals to P2. So now before I start, let me check whatever they are talking about. S, PK, it is this triangle here. You see? And then the next one, it is what? PRK. It is what? PRK. So when they are saying about PRK, they are basically talking about this one. PRK, you see, it is the very same thing. So PRK. So they are gonna join there. It is just the very same thing. So now let's go. What is S? I wrote S and P2 here. So this is S. I told you to angle S, it is equals to P today. We were asked to prove, so I can say proven here because I was given. Now let's go to the second one. So now let's consider this thing here. From what I can see that my K2, which is this one, it is also equals to K2 because it is the very same triangle that is within and that is inside there. Can you see that? You see? So angle K2 is equals to angle K2. It is common. Let's go to the last one. Now, from what I can see here at the same time, I can see that angle P2 plus angle P3, it is equals to what? Angle what? Let me check here. I have to check something here. Angle P2, angle P3, it has to be equals to angle what? R2 plus angle what? R3. Can you see that? This one and that one. What is the reason? Sum of angles in what? In a triangle. Are you sure, guys? Am I clear, guys? Can I see what I'm talking about? So P2 ne, plus P3, it is equals to R2 plus R3, sum of angle in triangle. Therefore, triangle SPK similar to what? PRK. Don't forget this one, equiangular. You see, it has a mark. This one, it is like this. Pa. That is what I'm talking about there. You see, let's go to the last question. It is further given that SR it is equals to RK. SR it is equals to RK. So they are saying this one it is equals to that one. Prove that ST it is equals to root 6 RK. So basically they're talking about this whole triangle there. Okay, they're talking about this whole triangle. Alright, let me change papers. So now please be careful on this one, and please listen to me attentively, please, guys. I'm begging you, because like this is gonna be a very long calculation method, but it's the only way. So I will start by saying in triangle what? STK, because that's what the only one I'm using. I can now see that I have what? My 90 degree here. I told you. So it basically means that I'm gonna do what? My Pythagoras theorem. So ST squared is gonna be equals to what? TK squared plus what? SK squared. Pythagoras theorem there. And then but what? Now you are starting. But SK it is equals to what? SR plus RK. Let's go back here. SK it is equals to what? RK. They even told us there. So what does it imply there? It means you go to SK it is equals to what? 2 times RK. Is it balancing there? Is it balancing? Is it balancing there? I hope it balances, because we are gonna move now. We're gonna move. So let's move, ne? Let's move. Because we are given at the same time. What you can basically do now, we'll go back to our Pythagoras theorem now and bring it here. So now I'll have what? My ST squared equals to what? TK squared. But where there is SK there, ne? Where there is SK, I'm gonna put what? 2RK squared. Then I'm gonna simply say T squared is equals to TK squared plus 4RK squared. You see? Now this is gonna be an equation 1. You see? Now from 10.1.3, because we have proven some of the things, you can rewind and go back there, ne? So our SK over PK, ne? SK over PK, it is equals to PK over RK. It is the same as PK over RK. Just that my triangle is messed up now because I can't use it now. So similar triangles there. So now basically I'm breaking down what? This one, this thing here. I hope you know the method I'm doing now. You see, you are simply seeing what here, what I was doing there. For this one, you take the first, I need it is SP over PR is equals to what? First and last. Is it first and last? It is the last two, PK over RK. It is equals to SK over PK. You see that one, that method there. That's what I did there. So, but now I took what? SK over PK and PK over RK. That's what I did. You see. Now let's continue. Now I'm gonna cross multiply. I have my PK squared, ne? It is equals to what? SK times RK. Is it fine now? Still fine, ne? But now my PK, it is equals to, remember the story here, SK. I said SK is equals to 2 times RK, right? But manje, it's gonna be like this, 2 RK here again. Yeah, wanna manje. So I'm gonna leave it like that. So I'm gonna say but PK it is equals to TK given. I was given there in the statement, right? I was given. Go back to the statement, you will see what I'm talking about. I was given Uguti, they are equal there. Okay, so now we are gonna continue. Seems like my markers are dying. I'm gonna change markers here. Hey, yeah, ne? So now let's continue. Since PK it is equals to TK and it is given, so it means what? TK squared, ne? It is equals to 2 times RK squared. You see? Equation 2. Let me put it there. Let me put it there, guys. Let me put it there. I want to continue to here so that you are not confused. So I'm gonna do what? My simultaneous sub 1 into 2 into let me see 2 into 1 because I have my TK as the subject there. Okay, so now let's continue. So I'll take my ST squared is equals to TK squared plus 4RK squared, right? So now I will say ST squared is equals to what? What is TK plus 4RK? Now, be careful there. I just told you right now that my TK squared, it is the same as what? 2RK squared there. So now where there's TK squared, I'm going to write what? 2RK squared plus 4RK squared. So these ones are already like terms, right? So this one will be what? 6RK squared. You see? ST squared is equals to 6RK squared. Then it's gonna be what? When I square root there, root of ST squared is equals to root of 6RK squared. Therefore, my ST, it is equals to root of 6RK, because the square root, this one will be removed, and then I'm gonna be left with this one. Okay, it's a longer method, but that's how you do it, guys. Okay, so yeah, I hope you enjoyed, guys. Don't forget to subscribe. Thank you very much.